The Turks and Caicos is an archipelago of over 40 islands and small cays in the Atlantic Ocean. This UK overseas territory is known for its turquoise waters, extensive saline ponds, mangrove ecosystems, and abundant limestone shorelines. These areas provide a range of habitats for a diverse number of endemic and migratory bird species, including 16 resident seabird species and a wide range of shorebirds. Many of the feeding and nesting sites for these marine and coastal birds are in remote areas of the Turks and Caicos Islands, making them difficult to access. As a result, little is known about the important populations of birds that call the TCIs home. A collaborative project funded by the UK government's Darwin Plus Project and led by the University of Liverpool is currently being run to improve our understanding of seabirds in the TCI so we can better protect them. The Seabird team spends many months each year traveling to remote corners of the TCI in order to monitor and study the many seabird species that breed here. One of the species that is being studied during this project is the elusive Audubon shearwater that predominantly nests on remote offshore cays in both the Caicos and Turks banks.
Seabirds are one of the most threatened groups of birds globally and are important components of healthy marine ecosystems. They have key roles as marine top predators, link inshore and offshore environments, and can affect the health of coral reefs. We therefore need to understand the populations that breed in the TCIs because of this area's importance for this group of marine vertebrates. It is essential that we understand their distributions, population trends, and how they interact with their environment, so that we can ensure that they are conserved and protected. Audubon shearwaters are part of a group of seabirds known as tube noses, due to their highly advanced sense of smell, which helps them locate food in the oceans. Audubon shearwaters nest predominantly in small caves and crevices in limestone karst on inaccessible islands, and are mostly active at night, which is an anti-predation strategy. Most species in this group are highly mobile, travelling hundreds, even thousands of kilometres to find food and migrate. These behaviours make them one of TCI's lesser known and most understudied seabirds. Our team of seabird scientists works in challenging conditions to collect the information we need to assess the size and health of shearwater populations on the cays. Until this project started, we had very limited knowledge of this species in the TCIs. We now know from our survey work that there are hundreds, possibly thousands of pairs breeding here. We travel to the colony by boat, and once in suitable habitat, our team undertakes detailed searches of nest sites by eye. The birds nest deep in holes in the ironshore, so we have to go to great lengths to detect them. And we have a number of tools at our disposal to do this. Early in the season, we rely heavily on song meters, which are deployed near cave entrances to detect when the birds arrive back at their colony from their wintering grounds. These devices record bird vocalizations throughout the night when they are mostly active. During our main population surveys, we subsample the cays due to their extensive size by marking out small plots which we search extensively within. We also look for any signs of activity in the entrance of holes, including eggs, feathers, fresh guano, footprints, and lastly smell. Shearwaters have a very distinct smell that any shearwater scientist should be able to identify. And we use burrowscopes to confirm presence of incubating birds in places that we cannot see the nest. We have to regularly squeeze into tight caves to look for birds. Seabirds are less sensitive to red light than white, so we use red light head torches wherever possible during our surveys. Shearwaters are very vocal animals and are also territorial, which means that they will readily warn intruders with a loud, harrowing call. Therefore, we play recordings of vocalising, duetting males and females at potential nest sites, and we record any responses we get. Our survey work is hard. We survey for long hours, crawling on jagged ironshore rock, squeezing into small holes and walking long distances amongst cacti. And the weather conditions can be extreme, from baking sun with no shade to torrential rain. Nevertheless, the data gained are invaluable. We also work in some areas at night to compare our detection rates of nests during darkness, when the birds are more vocally active, to the information we collect during the day. From these comparisons, we can gain more accurate population estimates than if we only used daytime surveys. We are now also extending our work to track the at-sea movements of these birds, so that we can identify their important foraging areas, which are high priorities for protection. After catching the birds, we attach a miniaturized biologging device that records GPS locations of the birds at set intervals. This tells us where they go when they are away from the nest and how far they roam over the oceans in search of food. The information gained from this massive effort will firstly help us to gain new insights into the sizes of the populations we have in the Turks and Caicos Islands, and the habitats in which these birds breed that are high priorities for management. At present, there are a number of protected areas in the Turks and Caicos Islands, some of which were originally designated as important bird and biodiversity areas due to the large numbers of seabirds that bred there in the past. Seabird populations have not been monitored effectively for over 20 years. The new data that we are generating in this project will help the Turks and Caicos Islands government, as well as regional organisations, to identify the significance of existing protected areas for today's seabird populations. The data will also highlight any unprotected sites which are in need of protection to safeguard these animals into the future.